Opening. From the Berne Patent Office to the pinnacle of the universe. How did a humble patent clerk unravel the secrets of the universe with just pen and paper? Walter Isaacson Einstein, His Life and Universe, a global bestseller with over 10 million copies sold, hailed as a scientific epic, chronicles not only the legendary life of a genius but also reveals how curiosity ignited an era's spark. The name Einstein has transcended science, becoming a symbol of freedom, rebellion, and wisdom. How did he rise from an ordinary clerk to a titan who defined the 20th century? Let's step into his world to trace the path of his untamed mind. At the end of the 19th century, physics faced an unprecedented crisis. Newton's classical mechanics, dominant for 2 centuries, couldn't explain the peculiar behavior of light speed or the mysterious motion of atoms. Young Albert Einstein, born into an ordinary Jewish family in Germany, without a prestigious background or elite education, sparked a scientific revolution from a patent office in Bern, Switzerland, armed only with curiosity and a defiance of authority. This story is not just about formulas and experiments but an epic of dreams, struggles, and human brilliance. Through Isaacson's vivid prose, this book portrays how Einstein navigated the dual whirlwinds of science and life. From the miracle year of 1905 to the birth of general relativity, from anti-war speeches to tangled family relationships, he was both a world-changing scientist and a deeply flawed human. His rebellion, humor, and loneliness weave a complex portrait. By exploring this book, we'll journey from his childhood, through the peaks of scientific discovery, to his turbulent years as a public figure, and finally to his ultimate reflections on the universe and humanity. Einstein's journey belongs not only to him but to everyone who questions the cosmos and their place in it. Chapter 1. Childhood and Education: The Seeds of Rebellion. In 1879, Albert Einstein was born in Ulm, Germany, to a Jewish family. His father, Hermann, ran a small electrical business, while his mother, Pauline, filled their home with music and freedom. Yet, Einstein was no prodigy. He didn't speak until age 3, prompting fears of a language disorder. This delay didn't dim his curiosity. The compass from his father, its needle mysteriously spinning, captivated him with its invisible force. Isaacson writes, that compass became the spark of his lifelong quest to unravel nature's mysteries. Einstein's childhood overflowed with wonder. He wandered forests alone, observing falling leaves and pondering the motion of the wind. This fostered a knack for independent thought. At 10, he met Max Thomé, a medical student who introduced him to Kant's philosophy and Euclid's geometry. Kant's critique of pure reason led him to ponder the nature of time and space, while geometry's rigor became the cornerstone of his future theories. He once recalled, geometric proofs were like poetry, revealing the universe's order. His fascination with geometry wasn't just about logic, but a way to transcend everyday experience. In his diary, he wrote that geometry offered a dialogue with the universe. This feeling was especially strong in his youth. At 12, he tried proving the Pythagorean theorem with Euclidean geometry, devising a new path that, while not original, thrilled him. Such self-driven exploration taught him that mathematics was a language for uncovering nature's laws. He also read works by Carl Friedrich Gauss, whose ideas on non-Euclidean geometry hinted that the universe's shape might not be the flat space of intuition. This obsession with geometry laid the groundwork for the mathematical framework of relativity. Music, too, took root in this period. His mother taught him the violin, and Mozart's compositions revealed to him the mathematical essence of rhythm and harmony. He once said, "Music and physics are both expressions of the universe's order." This cross-disciplinary perception shaped his unique thinking. His academic path, however, was rocky. Einstein despised the rigid German school system, hating rote memorization and militaristic discipline. He clashed with teachers and was once told by a principal he'd never amount to anything. At 15, he moved with his family to Pavia, Italy, but dropped out, unable to adapt to the school system. He turned to self-study, devouring books on physics and math, from Newton's mathematical principles of natural philosophy to Maxwell's electromagnetic theory, building his knowledge base. Isaacson writes, Einstein's rebellion wasn't destruction but a relentless pursuit of truth. In 1896, at 16, he enrolled in a progressive school in Aarau, Switzerland. Its free atmosphere suited him, with teachers encouraging questions over memorization. He dove into advanced mathematics, captivated by the elegance of calculus. That same year, he entered the Swiss Federal Polytechnic in Zurich, where he met Mileva Mari, a Serbian woman passionate about science. Mileva's mathematical talent and independent spirit drew him in, and they debated Maxwell's equations and thermodynamics together. Their passionate romance, however, sowed seeds of conflict, as Mileva's traditional values clashed with Einstein's free spirit, foreshadowing their eventual marital strife. The Polytechnic, Einstein wasn't the top student. His mentor, Hermann Minkowski, noted, "He's a bit lazy, but his questions always cut to the core." Einstein preferred debating philosophy and science in cafes with friends like Marcel Grossmann, whose math notes later proved crucial for general relativity. After graduation, his nonconformist nature left him jobless in academia, leading him to a modest role as a third-class technical examiner at the Bern Patent Office. This seemingly mundane job offered him a quiet space to ponder the universe. Chapter 2. The Miracle Year 1. Ivy's intellectual storm. In 1905, at 26, Einstein, from his cramped patent office in Bern, published 4 papers that reshaped physics. Known as the Miracle Year, 1905 cemented his scientific legacy and transformed humanity's understanding of the cosmos. Isaacson writes, in 1905, Einstein was a comet streaking across the night sky of physics. His first paper proposed the light quantum hypothesis, solving the mystery of the photoelectric effect. Late 19th century scientists viewed light as a continuous wave, yet experiments showed that electrons emitted from metal under light depended on frequency, not intensity. Einstein boldly suggested light travels in quanta, like tiny packets of energy. Using Planck's quantum theory, he derived a formula for the photoelectric effect, perfectly matching experimental data. Picture shining a flashlight on a mirror. Light isn't a continuous stream but like ping-pong balls, each carrying fixed energy. This hypothesis earned him the 1921 Nobel Prize in Physics and laid the foundation for quantum mechanics. His second paper confirmed the existence of atoms through Brownian motion. At the time, atoms were still a debated concept, seen by some as mere theoretical constructs. Observing pollen grains jittering in water, Einstein proposed this was due to molecular thermal motion. Using statistical mechanics, he derived equations for molecular motion and size with stunning precision. French physicist Jean Perrin, inspired by this, measured molecular diameters experimentally, confirming Einstein's predictions. Perrin later said, "Einstein's equations convinced me atoms are real, not just hypotheses." The third paper introduced special relativity, overturning Newton's absolute concepts of space and time. The 1887 Michelson-Morley experiment showed light speed is constant in all reference frames, contradicting classical mechanics. Einstein proposed that time and space are relative, varying with an observer's motion. Imagine tossing a ball on a high-speed train. Inside, it moves straight, but to someone on the platform, it follows a curved path. Time and space work similarly. A moving clock slows and objects shorten. He derived the Lorentz transformation, unifying space and time. This theory revolutionized physics foundations. Special relativity not only shook science but sparked philosophical and cultural debates. It challenged intuitive notions of time, inspiring philosophers like Henry Bergson to rethink time's nature. In a 1922 debate, Bergson defended subjective time, but Einstein insisted time is a measurable physical quantity. This clash showed special relativity as both a scientific and intellectual revolution. Artists, too, were influenced. Italian futurist painters like Umberto Boccioni captured motion and time's relativity in dynamic compositions. Einstein's papers initially drew little attention, but physicist Max von Laue recognized their genius. In 1906, von Laue wrote to Einstein, "Your theory showed me time is no longer an absolute clock." Von Laue's support helped Einstein enter academic circles. Einstein's work drew heavily from James Clerk Maxwell's electromagnetic theory, which revealed light speed's constancy, which Einstein extended to all physical laws, forming the core of relativity. The fourth paper introduced the mass-energy equation, E equals mc. Einstein showed mass and energy are interchangeable, with 1 gram of matter holding energy equivalent to thousands of tons of explosives. This equation unveiled the universe's deep unity, paving the way for nuclear energy. Isaacson quotes Einstein, "E equals mc is the universe's secret, showing everything can transform." The miracle year stemmed from Einstein's unique environment and mindset. His patent office job exposed him to electromagnetic technology data, fueling his thoughts on light and fields. His friend Michel Bessot discussed philosophy and physics, suggesting thought experiments, like imagining chasing a light beam. Aleva proofread his papers, though her contributions remain debated. Einstein's success was a symphony of curiosity, collaboration, and persistence. Chapter 3: General Relativity, the Key to Reshaping the Universe. Special relativity addressed uniform motion, but Einstein pressed further, tackling acceleration and gravity. In 1915, he published General Relativity, redefining gravity as the curvature of spacetime. This theory explained planetary orbits and predicted light bending in gravitational fields. Its inspiration came from a thought experiment. A person in an accelerating elevator feels the floor press upward, mimicking gravity. Einstein deduced gravity isn't a force but the result of mass curving spacetime. Picture a heavy ball on a rubber sheet, causing it to sag. A smaller ball rolls along the curve toward it. This is gravity. Earth's mass warps spacetime, making the moon orbit. In 1919, British astronomer Arthur Eddington tested general relativity during a solar eclipse. On Partensipe Island, he measured starlight bending near the sun, matching Einstein's predictions precisely. On November 7, 1919, The Times headlined, "Newton's Theory Overthrown." Eddington's eclipse observations, conducted amid wartime tensions, symbolized science's borderless spirit, as a British team validated a German scientist's work. The results made Einstein a global sensation, though some questioned the data's accuracy due to observational errors. Later eclipses, like the 1922 Australian experiment, confirmed his predictions. General relativity revolutionized astronomy. In 1916, Carl Schwarzschild derived its first exact solution, predicting black holes, though Einstein himself doubted their existence. By the 21st century, the Event Horizon Telescope imaged a black hole, validating his theory. Isaacson writes, "The 1919 eclipse illuminated not just the stars but Einstein's name." General relativity revealed the universe's dynamic nature. Spacetime isn't a fixed backdrop but interacts with matter. It laid the foundation for black holes and cosmic expansion. The 2015 detection of gravitational waves by LIGO confirmed Einstein's century-old prediction of spacetime ripples. The theory also influenced art, with painters like Picasso exploring time's fluidity. Its development was grueling. Einstein spent a decade refining equations, often stalled by mathematical errors. His friend Marcel Grossmann introduced him to non-Euclidean geometry, a critical tool. Einstein said, "Without Grossmann, I might never have found the right equations." He also raced mathematician David Hilbert, who nearly derived the field equations simultaneously but conceded Einstein's priority. This history highlights science's blend of collaboration and competition. General relativity faced challenges. In 1916, Einstein proposed a finite, boundless universe, like a three-dimensional sphere. This clashed with Dutch astronomer Willem de Sitter's view of an infinite, expanding universe. Einstein resisted expansion, introducing a cosmological constant for a static universe. Hubble's observations later proved the universe is expanding, prompting Einstein to call the constant his biggest blunder. Yet, in 1998, discoveries of accelerated expansion revived the cosmological constant's relevance, showing Einstein's intuition's lasting impact. Chapter 4. Public Figure: Science and Humanity Intertwined. After 1919, Einstein was no longer just a scientist but a global icon. His tousled hair, playful smile, and anti-authoritarian vibe made him a media darling. Newspapers dubbed him the new Newton, some even likening him to Galileo. Yet, beneath the fame, he grappled with human struggles. His political stance, marriage, and cultural identity painted a complex, contradictory Einstein. Politically, he was a staunch pacifist. During World War I, he opposed German militarism, signing an anti-war manifesto, clashing with scientists like Max Planck, who valued political neutrality. In 1918, he spoke at Berlin University, advocating peace and global cooperation, earning students' applause. British philosopher Bertrand Russell, inspired by him, wrote, "Einstein's courage showed me a scientist's conscience can transcend borders." In 1933, as Nazis rose, Einstein's Jewish identity made him a target. His books were burned, his property seized, and he fled to Princeton's Institute for Advanced Study. In the US, he joined anti-fascist efforts. Yet, fearing Nazi nuclear ambitions, he co-wrote a letter with Leo Szilard to President Roosevelt, sparking the Manhattan Project. This decision haunted him. He wrote in his diary, "I opened Pandora's box but couldn't control its consequences." This tension reflects the complex interplay of science and morality. Einstein's stance on Zionism was nuanced. Proud of Jewish cultural revival, he supported a Jewish homeland in Palestine but opposed an exclusionary state. He debated physicist Niels Bohr, who saw nationalism as a source of conflict, while Einstein believed cultural identity could foster unity. In 1948, when offered Israel's presidency, he declined, saying, "I'm better suited to formulas than governing." Isaacson notes, Einstein's idealism made him both bold and naive in politics. His personal life was turbulent. He married Mileva Mari in 1903, having two sons, Hans and Edward, and an out-of-wedlock daughter. Mileva's mathematical talent aided him, but her traditionalism clashed with his free spirit. By 1914, their marriage soured. Einstein proposed a cold marriage contract, demanding distance while expecting household duties. They divorced in 1919, and he married his cousin Elsa, who offered stability but couldn't ease his loneliness. His daughter Ilse recalled, "Father was always thinking, leaving little time for family." His distance wasn't callousness but a focus on science and social causes. He championed human rights and equality. In 1931, visiting the U.S., he condemned racial segregation, supporting African American civil rights. Corresponded with sociologist Du Bois, discussing racism's roots and funding Du Bois's anti-racism journal, The Crisis. Du Bois wrote, "Einstein's empathy showed me humanity can cross color lines." Less known, he supported women's education, raising funds for a Princeton girls' school in the 1930s, declaring, "Intelligence knows no gender. Education is everyone's right." These efforts extended his scientific influence to social justice. His activism drew criticism from conservative scientists for meddling in politics, but he insisted scientists must uphold human dignity alongside truth. His humor and approachability shone through. He explained complex theories simply, telling reporters, "Relativity is like a minute on a hot stove feeling like an hour, or an hour with a loved one feeling like a minute." This knack made him a science communicator, inspiring figures like Carl Sagan. He found solace in the violin, once improvising with pianist Arthur Rubinstein, who joked, "You play well, but don't quit physics." Chapter 5. Later Years: Unresolved Mysteries and Philosophical Turn. In his later years, Einstein stepped back from science's forefront but never ceased probing the cosmos. He pursued a unified field theory to merge gravity and electromagnetism, without success. He challenged quantum mechanics' randomness, famously saying, "God doesn't play dice." This sparked decades-long debates with Niels Bohr. Quantum mechanics, pioneered by Planck and Heisenberg, posits that particle behavior is probabilistic. Einstein rejected this, believing the universe follows deterministic laws. In 1935, with Podolsky and Rosen, he published the EPR paradox, suggesting quantum entanglement's spooky action at a distance defied causality. Imagine two particles, miles apart, where measuring one instantly affects the other. Einstein argued this showed quantum mechanics was incomplete. Bohr countered that quantum rules transcend classical intuition. Isaacson quotes Bohr, "Einstein tried to tell God how to run the universe, but God has his own rules." In 1964, John Bell's experiments confirmed quantum entanglement, upholding quantum mechanics, though Einstein's EPR paradox fueled fields like quantum communication. Isaacson writes, "Einstein's skepticism advanced science, even if he couldn't accept its conclusions." His debates with Bohr were as much philosophical as scientific, pitting determinism against randomness. Einstein also turned to ethical reflections, troubled by science's dual nature, especially the atomic bomb. In 1955, with Russell, he issued the Russell-Einstein Manifesto, urging global nuclear disarmament, warning, "End war, or end humanity." He pondered freedom and responsibility, writing, "A person's true value lies in how much they free themselves from self-imposed limits." This inspired scientists like Carl Sagan to blend science with humanism. His regrets lingered, his unified field theory pursuit, deemed stubborn by peers like Wolfgang Pauli, who said, "Einstein chased an impossible dream." He felt guilt for neglecting family, writing to his son, "I hope you can forgive me for giving my time to the universe." Yet, his persistence and reflection revealed a scientist's quest for eternity. Isaacson writes, "Einstein's later years were a mortal's attempt to touch the eternal." Epilogue: Einstein's enduring light. Einstein died in 1955 at 76 from a ruptured aortic aneurysm. His legacy transcends time and space. His theories underpin modern physics, from GPS time corrections to gravitational wave detection. His pacifism and fight for freedom inspire justice and truth seekers. His rebellion and curiosity remain a beacon for dreamers. Today, Einstein's story resonates. Amid AI and quantum computing advances, his imagination reminds us that breakthroughs stem from bold questions. In 2023, D-Wave's quantum computing leveraged entanglement, tracing back to Einstein's EPR paradox. His anti-war ethos, amid climate change and global conflict, urges a human-centered approach. The Russell-Einstein Manifesto shaped the UN's nuclear non-proliferation treaty, influencing global security. Einstein's personal flaws, failed marriages, distant family remind us to balance ambition with connection. His humor and relatability show science's power lies in its human TIs. He said, "A person's value lies in what they contribute, not what they achieve." This is his epitaph and a call to us all. Einstein, his life and universe is more than a scientist's biography, it's a mirror of humanity. It shows that ordinary people, through curiosity and persistence, can change the world's course. Whether scientist, student, or everyday dreamer, Einstein's light urges us to question, embrace the unknown, and chase our own cosmic truth. His story assures us that within each of us lies a compass, pointing to our own truth.